Can you all hear me? Okay. Chalo, slowly we'll start whatever we have planned. Just a second. Okay, before I start, one more thing to tell you. Are you all free tomorrow for a class, extra class, Thursday, tomorrow 3 o'clock? Because last week I couldn't take place due to a bad health actually. So that particular class I need to take one extra class, 3 o'clock. I just need to take one class, and that is online, extra class. So I know many of you will have school or some, or many of you, in fact, that is the time when you come back from school actually. Okay, so that's why I'm plotting an online class. Chalo. And Friday you have 2 classes. My class also, GK Sir's class also. 2 classes you have, hybrid. Okay. I hope you know that. Anyways, chalo, let us start out with this thing, trigonometric functions. In calculus, you will see in further calculus and various applications of mathematics, although we will discuss trigonometric functions further, because that is what is exactly what we're going to use in the applications and calculus, because this particular chapter has more applications or in calculus basically. So when you learn calculus, in fact, so gradually you will have to have a in-deep idea of this particular chapter. Anyway, so the thing is, in calculus or in any other part of applications of mathematics, you will find that this trigonometric functions has a very huge application in calculus basically. What I'm trying to say is trigonometric functions and trigonometry. We are learning trigonometry, fine, but later on we are going to convert this into trigonometric functions. We are going to study in detail study of trigonometric functions, sine theta, cos theta, sine functions and cos functions. Graph of those functions also we are going to study. Periodicity of that particular function, graph of that function, and all those things we are going to study. Okay. So right till class 10, till your 10th standard, you have learned trigonometry in right angle triangle. We have learned trigonometry in right angle triangle, means applications of those sine theta and cos theta in right angle triangle. We have learned how do we define sine theta and cos theta, how do we define sine theta, cos theta, tan theta in terms of right angle triangle. We used to project that in right angle triangle, and we used to find those values like perpendicular by hypotenuse and all those things we used to do over there. In case of in case of right angle triangle basically. That's why we used to study up to 0 to 90 degrees. But I told you angles can go beyond 90 also. I have told you in the very first lecture of the trigonometry that angles can go beyond 90 degrees also. 360, 400, 200. Many angles can go beyond 90. In fact, angles can go from minus infinity to plus infinity. I have also told this thing. Okay. So gradually over here, right now, to extend this concept of angle, we will define this sine theta and cos theta in a new manner. That is, considering in a unit circle, actually, we are going to define sine theta and cos theta. Except that particular thing, yeah, we are going to use the same thing, the same concept of right angle triangle only, dropping perpendicular, then drawing right angle triangle, and of course, we are going to do the same thing. But this is a bit different concept. We are going to focus on the unit circle. We are going to project our sine theta, cos theta. We are going to define sine theta and cos theta with the help of a unit circle. Now, many of you might know all of these things. In case if you know this, it's fine. In case if you don't know, then obviously this will be a new lecture for you. Okay. But how the concepts are being derived, I have told you your concepts have to be very clear in case if you are going to sit for any competitive exams like ISI and all, even for JEE also. your competitive exams, sorry, your concepts must be very clear for all these examinations. The base concepts also must be very clear. Okay, like in case if you are in 12th or 12th pass, without doing this thing, you won't be able to do inverse trigonometry, which is the next chapter for you all. Not for 11th standard, but for 12th and 12th pass, I'm saying. In case if you're 12th and 12th pass, then genuinely after this chapter, you will learn trigonometric equations, and then post which you will learn inverse trigonometry. Okay, so slight difficulty in this chapter will actually create a problem in inverse trigonometry. Anyways, so we are going to define sine theta and cos theta newly in the unit circle. Now let us consider a unit circle. Now what is a unit circle? Unit circle means simply a circle of radius 1 unit. Okay. We are going to consider this particular unit circle given in this diagram over here, and here are the things. This particular distance is actually of 1 unit. This particular distance is actually of 1 unit. This much distance is 1 unit. Okay. Now, how do we define sine theta and cos theta over here? Sine theta and cos theta, in case over here, if we consider this, first of all, you understand this particular part. Here we have considered this point P. Okay. Here, this particular x axis is acting as the initial side actually. Okay. So this creates an angle theta, which is this angle, basically angle AOP. Okay. This particular angle AOP mentioned over here. Okay. So this OP is what? OP is making an angle theta with the x-axis in the counterclockwise, or basically the anti-clockwise direction. Okay, in the counterclockwise or in the anti-clockwise direction. Likewise over here, I have told you this one. This is your theta actually. This is your theta. This is theta, which is being shown over here. Okay. So this OP creates an angle theta with the x-axis in the anti-clockwise direction. Now over here, one more thing. This particular, I have told you this in my first lecture that you know, whenever we are following this particular convention, that this particular theta, whenever we are measuring the angle in the anti-clockwise direction, it is always considered to be positive. I have told you this thing in my first lecture. This is the standard convention we follow, that in the anti-clockwise direction, whenever we measure in the anti-clockwise direction, this convention must not be broken. In the anti-clockwise direction, theta is always positive. And when we consider the clockwise direction, in the clockwise direction, theta is always positive, negative, sorry, theta is always negative. In the clockwise direction, in this clockwise direction, this way, basically, I'm trying to say, this way, the angle is considered to be negative. Anyways, we come to the particular part. How do we just, what is the relation between negative and the positive angles? We're going to see with the help of these T ratios actually. T ratios means the sine theta and cos theta. We're going to discuss over here. Okay. Somebody has sent some chat. Just a second. Let me see. Saurabh, so one question. Yes, your one question. Please say the question. Saurabh. In the DPP sheet, there is a question. These are some special questions I haven't discussed in the first lecture. Finding the angle between the hour hand and the minute hand. I guess you are asking for the same, right? Angle between hour hand and minute hand. I haven't done that in the first lecture, so gradually I'll discuss that in the DPP discussion lecture. Okay, when we discuss the JEE practice problems, so gradually we're going to discuss over there itself. In the daily practice problem discussion and in the special problems or the standard problem solving sessions you have. So we're going to discuss those things over there itself. Okay. These are some standard problems. You know, this particular angle, the one which you are asking, finding the angle between the hour hand and the minute hand actually. I'll show you the shortcut also to find it, because the shortcut is actually used to find out in the competitive exam. Like over, I'm telling you, once year, I think 2000 and 2000 and which one? 2019 most probably. 2019 there has been a question on this particular thing. Although standard question, not so easy question. See, directly you won't get questions based on that. That find the angle. What is the angle between this particular hour hand and minute hand? Some time will be given. Let's say 4:30 will be given, and you are asked to find out what is the angle between the direct questions won't be given. They'll twist the question and they'll give it to you. I'll discuss those questions also. But the thing is, these particular things I'll discuss in the problem discussion session. You know, these are not asked, normally these are not asked in your JEE sessions, and ISI also rarely these problems are asked, like angles between hour hand and minute hand basically. Rarely these are asked actually. Okay, so gradually we are going to discuss this in the problem solving session. Okay. There's a shortcut also, there's a very nice shortcut to find out the hour hand and the minute hand. In case if you know, it's fine, but in case if you don't know, to find out the angle between the hour hand and the minute hand, the formula is 30 hours minus 11 by 2 minutes. This is the shortcut to find out. We take mod because since it's an angle, we consider this to be positive actually. Okay, to find out the hour hand and the minute hand, angle basically, to find out the angle between the hour hand and the minute hand, this is the shortcut way. The formula is 30 hours minus 11 by 2 minutes. Suppose it's 4:30, you take 4 over here, replace hour by 4 and minutes by 30, sorry, minutes by 30 simply. 30 minutes, 4:30 is there, so replace hours by h by 4 and minutes by m by 30, so you'll get the angle from there. So just simply calculate this, you'll get the angle. This is a shortcut way. And based on this formula also, there has been question in pre-RMO. Okay, so I'll tell you the shortcut. This is a shortcut. I'll tell you the formal way also. How do we solve this? Formal way is also very easy. Anyways, let's continue with this. I'll discuss in problem solving session. So coming to this particular part, we are defining sine theta and cos theta with respect to the unit circle. So this standard convention must not be broken, that we follow this anti-clockwise direction as the positive angle and clockwise is the negative angle. So sine theta is defined in this way. Suppose if we consider this much distance, we consider this point P over here, this particular point P, and we consider this much distance from the origin actually, origin 0, 0. Okay, this much distance we are considering. Okay, and this is a unit circle basically, so radius is actually 1 unit. Radius is 1 unit. So how sine theta and cos theta are defined over here in the unit circle? Sine theta is actually the y coordinate over here. This particular y coordinate is given by sine theta, or cos theta is actually x coordinate. This is your x coordinate. This x coordinate is the cos theta and y coordinate is the sine theta. Why? Simple logic. If you drop a perpendicular from here on the x-axis, suppose if you are dropping a perpendicular over here, by your simple 10th standard logic, I'm telling you, this much distance, suppose if this is x, suppose if this is x, obviously this is y. Okay, this is x, this much distance is x, and this is y. So what is sine theta? Sine theta will be y by, means perpendicular by hypotenuse. This is your perpendicular y, and what is hypotenuse? This is the radius basically, isn't it? This much is the radius, because this is a unit circle. If this is 1 unit, this entire thing is 1 unit. Obviously, this much is also the radius, basically 1 unit. This much is also 1 unit. So it is actually perpendicular by hypotenuse. So this is actually y by 1. Okay, y by 1. So which is just simply 1. Sine theta will be simply y by 1. Okay, you may write it in this manner, that if suppose this is actually your point M, suppose if this is your M, then this is actually sine theta will be what? Sine theta will be MP by OP. MP by OP, which is nothing but y by 1, which is y. So this is actually what you're getting. Sine, if this coordinate is x comma y, this particular coordinate is x comma y. So gradually what we are getting is sine theta is actually your y coordinate. Your y is actually sine theta. Same thing goes for cos theta. What is cos actually in right angle triangle? If we define cos, ultimately we are using the concept of right angle triangle, but on a slightly different note, we are using it on a unit circle actually. We are using it on a unit circle. So the same logic, if over here, if you just follow that, this is y is basically sine theta. So similarly, cos theta will be what? Cos theta will be base by hypotenuse. So base is actually OM, and this particular length is actually OP. Hypotenuse is basically OP. Ultimately, so this is x by 1, so this is x. So x coordinate is actually cos theta. So this is what exactly what we are getting. X coordinate is cos theta, x coordinate is cos theta, and y coordinate is actually sine theta. This is the definition of cos theta and sine theta in a unit circle actually. Simple idea, nothing difficult over here. The very simple idea I'm using. Okay, so this is exactly what you're happening. I'll show you this thing, few more points. You will see from here, this particular thing, just see this diagram. If we consider this unit circle once again, suppose this particular angle, if we are considering, you know, cos 90 is what? 0. All of you know this thing. Cos 90 is 0, sin 90 is 1. Why we are getting this thing? If I just simply define this thing, just let's say a unit circle, if I am considering, this point is 1 comma 0, this is 0 comma 1, this is minus 1 comma 0, and this is actually 0 comma minus 1. These points I am marking over here just for a reference over here. So this much, suppose if I am traveling 90 degree, this much angle is, suppose if we are considering this much angle, this is 90 degrees. Okay. So obviously I told you just now, what is cos theta and sin theta? Your x coordinate will be cos theta, y coordinate will be sin theta. Anywhere you can take over here. Suppose I am taking the triangle like this manner. I'm traveling 90 degrees basically. This theta is 90 over here. This theta over here is 90 over here. So if theta is 90, obviously what is cos theta? Cos theta is cos 90. So which is this value basically, cos 90. This is actually your cos 90. Cos 90 is 0, and sine, and this is your sin 90. This is your sin 90, which is 1. And if suppose someone asks you what is cos 180 degrees basically, first you will identify what is theta. In a unit circle, if suppose someone asks you what is 180 degrees, you take the unit circle over here. What is cos of 180 and sine of 180? I told you beyond 180 now we have to study. So first you will identify theta. What is theta? Theta is actually 180. So this much you have theta. This is 180. This is 180 degree. Okay. We have 1 comma 0. This is 0 comma 1. This is minus 1 comma 0. And this is 0 comma minus 1. So what is theta? Theta will be cos theta. First of all, theta is 180 degree over here, and cos theta will come over here, which is cos 180 over here, which you will get cos 180, and this is actually the value of sin 180. I told you this is actually this thing which we follow, standard convention is in the anti-clockwise direction. So we are measuring the angle in this way. So 180 degree, first identify what is theta, and then this is where your this particular thing, your angles actually lie actually, cos 180 and sin 180. This sin theta is what? This theta is basically this particular angle which is being created. Angle which is being created. Means this particular angle AOP is which is being created over here. Okay, so first identify theta, and that is exactly you will have your value. If suppose the question has been in this manner, what is cos of 270 degrees and sin of 270 degrees? Suppose the question would have been this manner, what is cos of 270 degrees and sin of 270 degrees? On a unit circle, you will say this particular, this is actually 180 degree and plus 90 degree, which is 270 degrees, which will come over here. This is 270 degrees. Basically what we do, this is 0 degrees, starts from 0, this is 90, this is 180, this is 270, and then we come back to 360 actually. And then once again we start the rotation. If whatever is the angle, basically we start the rotation once again on a unit circle. This is what we follow. Okay, when we rotate actually. So this is up to this we have 180, and this much if you travel, this is 270. Okay, this much is 270. So if suppose someone asks you what is cos 270 degrees, cos 270 degrees and sine 270 degrees. Cos 270 degrees and sine 270 degrees. What you will say from here? This is actually what this point is 0 comma minus 1. You're lying over here, right? You're coming to this particular quadrant. Yeah. So this is actually 270 degrees actually. So you're coming over here. So obviously over here, cos theta will be what? Cos theta will be 0. Means this particular cos 270 degrees will be what? This is actually cos 270. This is actually cos 270 and this one will be sine 270. Means cos 270 is 0 and sine 270 is minus 1. Is this concept clear to you? What we are trying to discuss, that the unit circle. Mostly you will find this in any maths book. You will find this in your boards book also. You will find this particular thing. But is the concept clear to you? What we are trying to depict over here. Okay. So gradually over here, this is the idea. You will see further. We will come to the quadrant system. I'll teach you the quadrant system. Let's see some points over here. Always follow this thing. Standard convention must be followed. The conventions regarding the measure of arc length on the unit circle are same as of that on the angle. Same thing, same idea. Basically, the convention is whenever you're measuring the angles, basically theta in the anti-clockwise direction, theta is positive, and in the clockwise direction, theta is negative. Whenever we have this thing, if suppose on the quadrant, in the quadrant, suppose if this angle is 45 degrees, then this particular angle will be minus 45 degrees. Okay, this particular angle on the clockwise direction would be measured in the minus 45 degrees. Okay. Now suppose if I ask you the questions, where does minus 120 degree lies? Minus 120 degrees. Where does minus 120 degree lies? Minus 120 degree. This is minus 180. This much is minus 180. We are measuring in the clockwise direction. This is entire this particular circle, half circle is actually minus 180 degrees. So minus 120 will be somewhere over here. Minus 120 will be somewhere over here. Minus 120 is somewhere over here. So it's a third quadrant angle. Okay, the third quadrant angle. This is the first quadrant, second quadrant, third quadrant, and the fourth quadrant. So this is actually minus 120 degree will be a third quadrant angle. And I have told you, try to visualize angles in terms of radian measures, because right now I am showing you in degree measures. Slowly we are going to move on to radian measures, and bigger angles we won't consider in degree measures. Basically, very bigger angles we will always consider in terms of radian measures. Okay, this is the idea. And sine theta and cos theta, which you have seen from here so far, you will see. Even you consider, let's say from this particular diagram I'm showing, even you consider sine 360 degrees. Sine 360 means this particular entire rotation. Means you are once again coming back to this particular part. Sine 360 means entire rotation. Sine 360, which is the same as sine 0. Whenever you are come back to the fourth quadrant, basically, sine 360 is the same as sine 0. Okay. This particular coordinate was what? This particular coordinate is actually 1, 0, right? This is 1, 0. So sine 360 will be 0 and cos 360 will be 1. Okay. Basically, cos 2 pi. Cos 2 pi is 1 and sine 2 pi is 0. Okay. So this will keep on repeating itself. Likewise, whatever rotation you will take, no matter how many rotations you will take, very bigger angles you are taking, 2 pi, 3 pi, 4 pi, 100 pi basically. So this will keep on rotating. Basically, sine theta and cos theta is defined for all types of angles. Sin theta you will find out for every type of angles, all types of angles, complementary, supplementary, or even for acute angles, whatever angles you will take, sin theta, cos theta will be defined. You can define sin theta and cos theta. You can find out the values of sin theta and cos theta for all types of angles. It may happen that tan theta and cot theta might not be defined for certain angles. Same thing goes for cosec theta and sec theta. It might not be defined for certain angles, but sin theta, cos theta is absolutely defined for all types of angles. The two major base angles, sin theta and cos theta, is defined for all types of angles. Okay. So gradually over here, sin 360 and cos 360 will have the same value. Means sin 2 pi and cos 2 pi. 2 pi means 360 degrees basically. So gradually over here, what I'm trying to say, what you have seen so far, sin theta and cos theta lies between, this particular information says, sin theta and cos theta lies between -1 and 1. This is actually the range of sin theta and cos theta. Sin theta and cos theta, basically your values of sin theta and cos theta lies between -1 and 1. It will never exceed -1 and +1. You come to this particular part, every time you have seen, we have considered in a unit circle basically, either it was -1 or +1 or 0. The values basically I'm saying, the values is always lying in between -1 and +1. It is never exceeding -1. You have never seen it's -2 or 2 or something. Okay, max to max it can be -1. Sorry, max to max this can be 1, and minimum this can be -1. This particular point is -1, 0. Okay, maximum this can be 1, minimum this can be -1. Minimum value of this is actually -1. So this is actually the maximum and minimum value I'm saying. This is this particular one. This one is actually the maximum value. This is the maximum value, and this is the minimum value. Minimum value of sine function and cos function is actually -1 and +1. Okay. This is one more point. Okay. I'll come down to the quadrant system also, but this is the overall idea which you will see over here. Okay. Now coming to the quadrant system. One more point is there, third point, that both sin theta and cos theta, I just told you, sin theta and cos theta is defined for all angles. Every type of angles you will see, sin theta, cos theta is defined. You will see for only tan theta for other functions like tan theta and all. Maybe it is not defined at some particular points. I'll tell you where it is not defined actually. Okay, I'll tell you that as well. Come down to quadrant system. Now, what is the quadrant system? This is the most important thing. Maybe some of you know this thing. It's fine. I'll just say for them, those who don't know, and in case if you know, then gradually this will be a revision for you. The thing is, suppose if I consider the 4 quadrants, and suppose if I take this much distance, let's say. Let's come down to the first quadrant. Part by part, in each of these quadrants, we're going to discuss. In the first quadrant, suppose if I'm coming to the first quadrant, and if this is your actually point P, suppose I'm considering P is XY. With this much distance, suppose I'm considering this much distance is actually R. Suppose this is actually a unit circle. I'm not drawing the circle once again, continuously drawing the circle. Basically, we will consider this to be a circle, somewhat like this. Okay. So gradually I have to show you different things over here. So I'm not drawing the circle continuously. So this particular angle will actually move on with different quadrants in your quadrants actually. This will move in various quadrants. So what I do, I consider this much distance. Let's say this is actually your R distance I'm considering. I drop a perpendicular from here on the x-axis. Okay. Let's say this much distance will be x, this much distance is x, and gradually this much distance is y. Okay. This distance is x and this distance is y. What are we going to do is we are going to define sine theta, cos theta for each of these quadrants. Simple. So sine theta will be what? Sine theta will be y by r perpendicular by hypotenuse. So sine theta, let's say this, if this is angle is theta, suppose. So sine theta will be what? Sine theta is defined for y by r. Okay. And cos theta will be, in first quadrant, x and y are positive. Both x and y are positive, isn't it? In the first quadrant, both x and y are positive. So sine theta will be y by r, and r is what? R is the radius of the circle, basically, which we are going to consider. So r being the radius, it is always positive. Obviously, radius is a distance, basically. So this is always positive. As you move on the radius, as you move on this particular triangle, this will always, radius will always tend to become positive. Cos theta will be what? Cos theta will be base by hypotenuse x by r. Both x and y being positive, sine theta, cos theta are positive. If sine theta and cos theta are positive, so gradually other t ratios will be also positive. Tan theta, which is sine theta by cos theta, that is also positive. Same thing goes for the other t ratios. Sine theta, cos theta, tan theta, cot theta. All these t ratios, the 6 t ratios will be positive in the first quadrant. Concept is the same. You consider the triangle over here, right angle triangle. We take this right angle triangle, consider this distance, x distance, y distance, and simply the radius of the circle, and we simply see the t ratios. Okay. Very simple idea. This particular sine theta and cos theta will be positive, so as the other t ratios. So gradually over here, I am writing all the t ratios, 6 t ratios are positive. So I am writing all over here, which means all t ratios are positive. Okay. All t ratios are, all 6 t ratios are positive. Sine theta, cos theta, tan theta, cot theta, cosec theta, and sec theta. All of these are positive. Okay. If sine and cos are positive. Coming to the second quadrant, what happens in second quadrant? If you take the same situation and take the projection over here in the second quadrant, what happens in that case? In the second quadrant, suppose if I take on the second quadrant, if I have somewhere over here, I take the radius is always positive. I told you this is the distance, radius. This is always positive. And here I drop the perpendicular. This is theta angle, and this much distance being x distance. X distance, and this is the y distance. Okay. So here, first of all, x is negative, y being positive, but x is negative. In this case, x is negative. So sine theta is what? Sine theta will be y by r. No problem with this because y is positive. Sine theta will be y by r. Sine theta will be y by r. It is positive. But in this case, cos theta will be over here, due to this x is negative. X is negative over here in the second quadrant, x is negative. So obviously cos theta will become negative. Cos theta will become negative. Sine theta is positive, but cos theta will become negative in this case. Cos theta will become negative. Basically x by r, no? So obviously this will become negative, minus x by r. Okay. So if sine theta is positive, cos theta is negative, so as tan theta will be negative in that case. All other t ratios are negative except cosec theta, which is the opposite of sine theta. Isn't it? Cosec theta is what? 1 by sine theta. So only cosec theta and sine theta is positive in the second quadrant. Cosec theta and sec theta will be positive in the second quadrant. So I'm writing sine over here, which means sine is positive, and the opposite of sine, which is actually 1 by cosec theta, basically, that is sine theta. Sine theta and cosec theta are the two t ratios which are positive in the second quadrant. So I'm writing sine in the second quadrant. Generally we consider sine over here. So all t ratios are positive in the first quadrant, and sine is only positive in the second quadrant. Okay. Gradually the same logic applies in the third quadrant also. The same logic will apply in the third quadrant also. Over here, suppose if we consider this much distance is r, and this is your x distance, and this is your y distance, suppose. Okay, so here what is positive? Tan is positive gradually. Why tan is positive? Because over in the third quadrant, both x and y are negative. In the third quadrant, both x and y are negative, isn't it? Both x and y are negative in the third quadrant. So gradually for tan theta, you will have y by x basically. Why y by x? Because over here, whenever you are taking perpendicular by base, actually for tan theta I'm saying, whenever you are taking perpendicular by base. So what is tan theta? Tan theta for in a right angle triangle is what? Perpendicular by base. So if this is a perpendicular and this is a base, y by x you are taking. So obviously over here, y is negative, x is also negative. So negative will cancel out. So tan will become positive. All other t ratios are simply negative. Sin theta is negative because x is negative, y is also negative, cos theta is also negative, sin theta is also negative. Only tan theta is positive due to this particular idea that minus minus gets cancels out from here. Negative simply cancels out. We have y by x over here. Simple. Okay. Tan theta will be y by x. So over here also, what is positive? What else is positive? Opposite of tan theta, which is cot theta. Isn't it? 1 by tan theta is actually cot theta. Basically, cot theta is 1 by tan theta. Opposite of tan theta. So tan theta is positive and cot theta is positive. So gradually over here, I am writing tan over here because tan is positive in the third quadrant. And similarly, by the same logic, you will see in the fourth quadrant, by the same logic, what you will do, you will just simply do the same idea. You will take the triangle over here and simply draw the, and simply find out what is sin theta, cos theta, gradually what I am doing from here. Similarly, you will find out in the third quadrant, sorry, in the fourth quadrant, cos is positive. Cos is positive, so I'm writing cos over here. I'm leaving this work for you. Simple idea, all sine, tan, cos, basically. That's how we remember all sine, tan, cos. Now you all will find out different ways to remember this. It is up to you. There are a lot of shortcuts way to remember this. Like one is the ASTC. ASTC way to remember this, all sine, tan, cos, basically. All sine, tan, cos. So normally students find different ways to remember this thing. Okay, ASTC actually. Okay, now this is up to you how you remember this. Okay, so this is the overall idea. Any questions here? Add sugar to coffee. This is also one popular way to remember. I am telling you, it is up to you how you remember this. It is up to you. There different ways are there. All sine, tan, cos. Just don't get confused with this particular quadrant. Okay, however you remember, whatever way you remember, just don't forget about this quadrant system. All sine, tan, cos. Okay, simple idea. Many of you know this thing, I guess. In case if you don't know, then this is a new idea. Angle, idea of the angle is very important. You have to have the idea of the angles. Let us say, for instance, you will see from here. Let me show you here itself. If suppose someone asks you what is sine 750 degrees, suppose sine 750 degrees, how will you find out that sine 750 degrees? What you will do over here, first of all, I'm not coming down to the value. First of all, you have to identify whether sine 750 degrees is positive or negative. This is the question. This is my simple question. This much idea you should be having to identify the angles, whether those are positive or negative. Output is whatever output you're getting is positive or negative. This much idea you must be having. Okay. So gradually over here, suppose if someone asks you what is sine 750 degrees, sine 750 degrees, what you will do? Over here, what you will do is you will first take, you start from 0 degrees. So first you will start from 0, go to total we have 360. Then once again we will turn from 360 to 720, right? 360 plus 360. Once again I will turn 360 plus 360, which is 720, and post this you are going 30 degrees. How much? 720. So 30 degrees extra. 30 degrees extra. Okay. Total this much we have 720, and post you are going post 720 you are going 30 degrees extra. So that's why you are getting this particular. So over here this is a first quadrant angle, 750 degrees actually. So gradually this will be positive over here. I'm not coming under the value over here, but gradually this is the way. You must be identifying how the angles are, whether positive or negative. Sine, whatever you're taking, is positive or negative. Okay. In the first quadrant what? Sine is the first quadrant angle, and all the t ratios are positive, right? All the t ratios are positive. So gradually over here, sine 750 degrees is actually a positive angle. Now you all tell me, what is sine minus 200 degree? Is this positive angle or negative angle? Is this positive angle or negative angle? And in which quadrant is sine minus 200 degree lying? Is this, because your quadrant will decide whether this is positive or negative. Don't come to the output, just simply give the answer whether this is negative angle or positive angle. Minus 200. So gradually you only think of how you will take the direction. Minus 200 is there. So generally you have to take the clockwise direction. You all tell me. So whether sine minus 200 degrees is negative angle or positive angle. Means output, whatever the value will be negative or positive. Absolutely correct. Third quadrant and positive. Third quadrant and positive. Simple idea. In a this particular quadrant, if you consider sine minus 200 degrees. So gradually you are starting from minus 200, means this much is actually minus 180. This is minus 180, minus 2 pi basically, minus pi, sorry, minus pi, minus 180. And you are going this much, let's say about this much, minus 20 degrees more. So you are reaching minus 200 degrees. So your minus 200 will be somewhere over here. Okay. And it's a third quadrant angle. So gradually over here, sine is positive, all sine tan cos. So in the second quadrant over here, this is the second quadrant, not third quadrant. This is the second quadrant angle, right? So all sine. So this is a positive value. Positive is fine, but your third quadrant is wrong. This is the second quadrant angle. So gradually over here, sine minus 200 degrees will give you positive value. Okay. Likewise, we are going to find the values of different angles if given. So in general, we have this thing. In general, actually, we take in this manner that in a quadrant system, what we do, this much you all should know actually. In a quadrant system, if you take any angles over here from the first quadrant, fourth quadrant, likewise, okay, you're taking, let's say 0, 2 pi, 4 pi, 6 pi and all, right? 0, 360 and so on. But it means 0, all the even multiples, the multiples of 2 pi angles basically. Okay, 0, 2 pi, 4 pi, 6 pi. Okay, this much is what? This much is actually, whenever you are turning, like this much is 2 pi. Then once again you are turning, total this much is 4 pi. 2 pi plus 2 pi basically. 360 plus 360. Then once again you are turning 2 pi plus 2 pi, once again 6 pi basically, and so on. So gradually over here, all the even multiple angles of 2 pi basically, all 2n pi angles will come over here. All the multiples of 2 pi angles, basically 0, 2 pi, 4 pi, 6 pi, 8 pi and so on. All the even multiple angles will actually start from here. So, or basically will come over here. So 2n pi basically, 2n pi angles means all the even multiple angles actually. even multiples of 2 pi actually. And odd multiples angle will come over here. Odd multiples odd multiple means 2n plus 1 pi. Odd multiple angles will start from here or come over here. Odd multiples of pi, like 180 pi is there, 3 pi is there, right? This much, whenever you're traveling, this much is pi. Okay. Then once again you're traveling pi plus pi. So plus 2 pi. Basically you're landing up to the second quadrant, which is actually pi plus pi means 3 pi. So all pi, 3 pi, 5 pi will actually land over here and so on. So this much you should have the idea that where is the even multiples of 2 pi is actually standing and where this the odd multiples of pi is actually standing. Even multiples of pi and where the even multiples of pi angles are generated and odd multiples of pi are generated. Okay. Whatever even multiples will come and end over here and even multiples will come and end over here and odd multiples will come and end over here. Okay, you can write down as a note over here. Okay. Up to this, any questions do you have? Any questions on whatever we have done so far? So far what we have done? So far we have just done the quadrant system. Defining sine theta and cos theta in a new manner in a unit circle, taking with the help of a unit circle we are defining. Later on I will show you an animation actually. What happens when you this unit circle completes a full rotation, then sine theta is being defined over there. I'll show you that particular animation that is I've saved over here. So gradually, do you have any questions up to this, whatever we have done so far? Defining sine theta or defining any other content, if like in case if you're having any doubt. Quadrant system, all clear? Okay, great. So now one more point regarding this particular thing, you may write down as a note. Observation basically. What happens if you just consider the same, same unit circle over here, not the unit circle, basically consider the circle over here. I'm defining it on a general note I'm defining. Suppose, for instance, does not looks like a circle, but anyways, so suppose over here at I take a point over here, suppose point P. Okay, I have told you this thing that if this is theta, this angle is theta, this point P, this is actually cos theta and sine theta. Okay, let's say this much is the radius of the circle, this is R suppose, and let's say you drop a perpendicular. If this much distance is X, then this is Y actually. Okay, so if this much distance is theta actually, if this is theta, then this is, how much is this distance actually? For this angle basically, this is minus theta. If this is theta, then in the counterclockwise direction, sorry, in the clockwise direction, then this will be theta, minus theta, isn't it? This will be minus theta. If you draw the same perpendicular, let me use a different pen. This particular distance is R suppose. This point is actually, if this is minus theta, if this angle is minus theta, so gradually this point P is now cos of minus theta, because this is theta, theta is minus in this case, negative of theta. So basically this will be cos of minus theta and sine of minus theta. cos of minus theta and sine of minus theta. Okay. This much distance remains the same. This is x. This much distance is x, and this is actually y. Okay. Only theta difference, the difference between the previous thing, over here we have theta and here we have minus theta, because we are measuring in the clockwise direction. So if this is theta, then this is minus theta. So gradually this point P will be cos of minus theta and sine of minus theta. So we can define cos of minus theta, negative angles basically, cos of minus theta and minus sine of minus theta also in this, with this particular context. Can you easily see from here? Cos theta, basically. Cos theta is what actually? X by r, basically base by hypotenuse. Isn't it? Base by hypotenuse. This x is always positive. Only y is negative in this case. X is always positive. For this one, I am telling you, for this one, for the first quadrant. For the first quadrant, cos theta is actually how much? X by r. But for this quadrant, whenever we are measuring in the clockwise direction, cos of minus theta will be x by r. Same thing. Cos theta is x by r over there in the first quadrant also, in the fourth quadrant also it is x by r. Cos of minus theta, because we have considered theta is negative in this case, so obviously theta will be minus over here. Cos of minus theta is actually the same as x by r, isn't it? So the same thing goes for over here. If you take sine theta, if you define for sine theta, what happens for sine theta? If you take sine theta in the first quadrant is actually y by r. Fine, because x and y both are positive in the first quadrant, so y by r. But over here in the fourth quadrant, if you measure in the clockwise direction, this sine of minus theta will be what? Sine of minus theta will be minus y by r, which is actually minus of sine theta. Sine of minus r minus theta will be what? Minus y by r. Y is negative in this case, so this is actually minus y by r. So this is minus y by r means minus of sine theta, because sine theta was actually y by r. Okay, sine theta was initially y by r. So basically you are getting minus y by r means minus sine theta. So sine of minus theta is actually minus sine theta. So this gives actually a very nice definition from here. As you can see from here that total this much distance, cos theta is not affected at any cost. Cos theta is not affected at any cost. Basically, easily you can verify cos theta is what? Cos theta is actually the same as cos of minus theta. Cos theta is the same as cos of minus theta. Okay. If someone asks you what is cos 45 degrees, cos 45 and cos minus 45 will both have the same value. Cos 30 and cos minus 30 will both have the same value. Okay. Also, I'm going to discuss this under odd function, even function, this particular part. But since we have already discussed this quadrant system, so that's why I'm mentioning this thing right now itself, because this is a part of actually odd function, even function. So cos theta is the same as minus cos of minus theta, but sine of minus theta is actually minus of sine theta. So that is why you're getting sine of minus theta is the same as minus of sine theta. This is a definition of even function. F of minus x is actually minus of fx. I'll tell you that as well. Anyways, but these are the two main important points which I'm trying to say. Cos theta is cos of minus theta and sine of minus theta is minus of sine theta. So overall what we have, the conclusion, what is the conclusion? Sine of minus theta For at any cost, sine of minus theta, these identities you must be remembering. Sine of minus theta is minus of sine theta. Okay. Same thing goes for opposite of sine, which is cosec of minus theta is minus of cosec theta. Tan of minus theta, similarly, tan of minus theta, simple. Tan of minus theta is what? Sine minus theta by cos minus theta. Simple idea, you remember in this manner. So minus sine theta divided by cos theta, which is what? Minus tan theta. Isn't it? Cosec minus theta is what? Cosec minus theta is simply 1 by sine of minus theta. Okay. 1 by sine of minus theta, this particular thing. Opposite of sine, basically, I'm saying. So if tan of minus theta is minus tan theta, so gradually cot of minus theta, opposite of tan, cot of minus theta will be minus of cot theta. Cot of minus theta will be minus of cot theta. Okay. But only two ratios are there. Only two ratios are there which will actually not change. That is actually cos, and the reverse of cos, that is sec. We have seen from here cos of minus theta is actually cos theta. So as the opposite of cos, basically, that is sec of minus theta is actually sec theta. Only cos is not affected by the negative angle. Otherwise, the other t ratios are actually affected. The other t ratios are affected by negative angles. Proof is just now we have seen. This is a proof. How we have proved. Is the concept clear? These things actually you must remember these things actually. You can visualize these things, but gradually you must be remembering simultaneously. You must be remembering all these things as well. Very small parts, and very helpful in calculus, in fact. Only cos is not affected. This way you can remember. Only cos is not affected. The other t ratios are actually affected by the negative angle. Clear? In fact, your identity, these identities which you have learned from your junior classes, this thing sine square x plus cos square x or sine square theta plus cos square theta is 1. Actually is what you can derive the formula, basically sine square theta plus cos square theta is equals to 1 from this unit circle concept itself. From this unit circle concept, you can derive sine theta and cos theta concept, this particular thing. Where is that unit circle? Take this unit circle itself. From this unit circle, you can derive sine theta cos theta concept. It's sine square theta plus cos square theta. Those identities which we have done. Sine square theta plus cos square theta is what? 1. You can derive from this particular idea logic itself. Like, see, if this is a unit circle, what is the equation of this particular circle? If this is a unit circle, then what is the equation of this particular circle? The general equation I'm telling you. You have done circles, right? In your 10th standard, you have done circle. Basics of circles. If this is a unit circle with radius 1, then what is the equation of this particular circle? Bolo. Simple question. It's a unit circle, not a point circle, I'm telling you. It's a unit circle, means radius is 1. Yes, x square plus y square is equals to 1. Radius is 1, so gradually 1 will be there. Right? On the right hand side, we have x square plus y square is equals to 1, where 1 being the radius. This is the equation of the circle, in case if you know this, equation of the circle is what? If radius is suppose, let's say radius is r, okay, and the center is at AB, suppose. Center of the circle is at AB. Like these are the coordinates of the center actually. So equation of the circle is given by x minus a whole square plus y minus b whole square is equals to r square. You all have done this in 10th standard, 11th, 10th standard. You have done this, I guess, basic thing. X minus a whole square plus y minus b whole square is equals to 1 is equals to r square. Sorry, r is the radius basically. Okay. Like this is the standard equation of the circle, but you know, we have a general equation also. We do under circle, that is, if you expand this thing, you get the general equation of the circle. Like there is a the general equation of the circle is actually given by this: x square plus y square plus 2gx plus 2fy plus c is equals to 0. Okay, this is the general equation of the circle. Anyways, so right now we focus on this particular part: x minus a whole square plus y minus b whole square is equals to r square. So in this case, what is the center? Center is at the origin, isn't it? Center is at the origin in this case. This particular circle, if you consider this particular circle, whenever you consider this particular circle, the center is where? The center is at the origin, 0, 0. So gradually over here, x minus 0 whole square, the equation basically will simply turn out to be x minus 0 whole square plus y minus 0 whole square, which is x square plus y square is equals to r, is in this case is 1. So x square plus y square is equals to 1. This is the standard equation of this particular circle. X square plus y square is equals to 1. The identity sin square theta plus cos square theta is equals to 1 comes from this concept only. Replace x by cos theta and y by sin theta. X by cos theta and y by sin theta. Otherwise, you have learned this in your junior classes from the very basic idea of right angle triangle. You have learned this. This particular thing, we are actually defining this particular identity with respect to this unit circle concept. Otherwise, what you have learned, this is nothing but Pythagoras theorem only. This sin theta and cos theta is nothing but Pythagoras theorem itself. In the triangle, when you used to consider this particular right angle triangle, okay, this is the perpendicular, base and hypotenuse actually. How do we used to define sin theta? Sin theta will be perpendicular by hypotenuse, and cos theta used to be base by hypotenuse. This is how we used to define. Okay. And what is the Pythagoras theorem stating? Perpendicular square, base square is equals to hypotenuse square. And this is exactly what we are having with this particular identity: sin square theta plus cos square theta is equals to 1. That's how we are deriving. This is nothing but Pythagoras theorem. In this particular identity, if you divide both sides by h square, this p by h is what? This is simply sin theta. So this is actually what you are getting: sin square theta plus cos square theta is equals to 1. This is how you used to do in 10th standard. Now we are deriving in with respect to this unit circle and all, right? The same concept itself, more or less, but over here, if you replace x by cos theta and y by sin theta, you will get the same identity. This particular, any point on this particular unit circle you will take, this is cos theta and sin theta. So gradually simply replace x by cos theta and y by sin theta, you will get this particular identity. Okay. A very well known identity, known to all of you, that sin square theta plus cos square theta is actually equals to 1. Right. I hope all of you know this thing. You are doing from your 9th standard trigonometry. Sin square theta plus cos square theta is 1. Okay. That's how you used to prove in 10th standard, this way. And the standard proof also I have shown you. Apart from this thing, there are other fundamental identities also. 1 plus tan square theta is equals to sec square theta. Let's discuss those as well, since we have started off with this discussion. Sin square theta plus cos square theta is actually 1. That's how we prove it. The unit circle proof also I have told you. Okay. The other identities like 1 plus tan square theta is sec square theta, 1 plus cot square theta is cosec square theta. This can be derived from this particular main thing itself. This is the fundamental identity which you all know. The other identities can be derived from this sin square theta, cos square theta identity itself. What do you do? 1 plus tan square theta. There is one more identity. 1 plus tan square theta is 1 plus tan square theta is sec square theta. 1 plus tan square theta is sec square theta. This can be proved in a very simple manner. Sin square theta plus cos square theta is 1. If we divide both sides by cos square theta, we'll get this identity. In the first equation, if you just see from here itself, in the first equation, if you divide by cos square theta, both sides simply divide by cos square theta. And this is 1 by cos square theta. You simply get this thing. Sin square theta by cos square theta. This is what? Tan square theta. And cos square theta cancels out. And right hand side we have 1 upon cos square theta, which is nothing but sec square theta. Okay. And there is one more identity. These are fundamental identities you must be remembering. And the third one, that is 1 plus cot square theta. 1 plus cot square theta is actually cosec square theta. 1 plus cot square theta is cosec square theta. Again, similar way of proving this. What you will do? In the first identity, you will divide both sides by sin square theta. Okay, leaving the proof for you. These are the things which you must be remembering in order to prove certain identities. Okay. So 1 plus cot square theta is actually cosec square theta. 1 plus tan square theta is sec square theta, and sin square theta plus cos square theta is equals to 1. This is, all of you must be knowing this particular identity. Apart from these three identities, these are the you are doing from your junior classes. Apart from these identities, some special identities are there which I'm going to give to you certain special identities. You know, certain special identities in the sense those are used to solve questions, and you won't find those in books. Basically, you will find. I'll give you the formula sheets also for this particular chapter. There are a lot of formulas in trigonometry. I'll give you the formula sheet. My handwritten notes on formula sheets and are there basically for trigonometry. So likewise, you can revise those from that particular sheet itself. Okay. By today itself, I'll give it to you in your app itself. Apart from these things, first of all, what you will do, to remember these formulas, you must yourself write down somewhere, because so many formulas there, except I'm telling you, formulas are there. A lot of formulas are there which are going to do for your school or which you have done for your school. Apart from those, extra formulas are there which are going to learn for your competitive examinations point of view. Because for competitive examinations point of view, your NCERT formulas will not only help you. Your NCERT formulas which is given in your book will not help you. It will help you, obviously. You have to learn the basic formulas, but apart from those, only those things you won't have to. You will remember those things, but apart from those formulas, other formulas also are there. For fast calculations, you have to remember those identities. I'm giving it to you. 1 second, wait. Now these are taken for observations and not from any. You won't find this in any book basically, or you may also find in certain books might be given 1 or 2 formulas, but mostly are derived from observations. Just a second, let me find it. It's there in my formula sheet. So even I don't remember so many formulas, but nothing to do. You have to remember, but you have to. But there are techniques. Certain problems are there for fast calculations. If you remember, then gradually it will be easier for you only. Chalo. Extra formulas. Extra basic formulas. Extra basic formulas which you must be remembering. Sec squared theta times cosec squared theta is actually the same as sec squared theta plus cosec squared theta. If you remember these, I'm telling you, you will have the benefit. Sec squared theta into cosec squared theta is the same as sec squared theta plus cosec squared theta. Proof is very simple. You can see from the left hand side itself. If you break this, simply break this into sine and cos and simply prove it. To prove this, you can simply break this, simply break the left hand side, sec squared theta into cosec squared theta. So this is actually sec squared theta times cosec squared theta, means this is actually 1 by sec squared theta, means this is 1 by cos squared theta, and cosec squared theta means 1 by sine squared theta. Okay, the left hand side I'm saying, this is the left hand side. And on the right hand side, we have sec squared theta plus cosec squared theta. Again break this, let's see what we get from here. Sec squared theta means 1 by cos squared theta. Cosec squared theta means 1 by sine squared theta. Okay. Then what I do? I will take the LCM. Or you need not take the LCM. What we can do? Achha, let's do one thing. We can do it from here itself. Let's not do from the right hand side. We can do from the left hand side itself. We can do it from the left hand side itself. How will we do it from left hand side? We'll break in such a manner. In the numerator we have 1. Understand this part. In the numerator we have 1. We will write this one as sine squared theta plus cos squared theta. Now see, this is the most important part in mathematics, in higher standard mathematics, in 11th, 12th level mathematics. I'm telling you, till your 10th standard you have done sine squared theta plus cos squared theta is 1. Now you have to understand where to write 1 as sine squared theta plus cos squared theta. Opposite thing, where to write in mathematical identities, I can replace 1 by that particular value which will satisfy 1. Where to write 1 as sine squared theta plus cos squared theta. This is what you need to understand. Okay, no need to break the right hand side. We modify the numerator. We write this 1 as sine squared theta plus cos squared theta. All of you are doing this thing from your junior classes. Sine squared theta plus cos squared theta is 1. But now opposite thing you have to also understand where to replace 1 by sine squared theta plus cos squared theta, which sometimes becomes difficult. We have a lot of uses in calculus also. When you learn calculus, you will see that. Now simply divide individually. So this will become 1 by cos squared theta, and this will become 1 by sine squared theta. Okay, so this is what? Sec squared theta plus cosec squared theta. Okay, ultimately you have to remember the identity. You must be remembering. I'm telling you, you won't find this in any book, but you must remember for faster calculations. Mainly for JEE, I am saying, JEE point of view, these are very important. There have been questions. Next. Second one. Tan square theta into sine square theta is the same as tan square theta minus sine square theta. Tan square theta minus sine square theta. Tan square theta into sine square theta is the same as tan square theta minus sine square theta. Okay. One more identity. This you all will try the proof. Break the left hand side and verify. I'm leaving the proof for you all. This you all will try the proof. Tan square theta into sine square theta. Check how will you break this. You have to bring tan square theta minus sine square theta on the left hand side. So accordingly you have to break and see from there itself. Okay. Last one. Third formula. Third formula is sec cosec is done, tan sine is there, and one more was there. Cot and cos. Cot and cos. Difference of cot and cos. Cot square theta into cos square theta is cot square theta minus cos square theta. These three identities are there. If you remember, this will help you in fast calculations. Okay, this will help you in fast calculations. Okay. Remember these three identities. Apart from these three basic identities, let me keep under box this particular identities. Apart from these three, you must be also remembering those three identities. I'm telling you, whatever formula you're getting, write down somewhere, create your own formula book. I'm telling you, this will help you actually in the remembering the formula itself. What I used to suggest every time, write down make your own formula book, because there are a lot of formulas, or in your room, in your study table, write down formulas and paste it on the wall. Just study that, watch the formula, read the formulas every day. You will remember the formulas, because you have to remember the formulas. Okay, because you're sitting for competitive examinations. Which one? Proof of the which one? Second one. Second one or third one? Which one? I think this can be proved sine square theta and tan square theta. Wait, here your chats are delayed over here. 1 second. Third one. Okay, third one we have cot square theta and cos square theta. What you can do, cot square theta and cot square theta, cos square theta. What you can do, best is what we can do is we can start from the right hand side. Best will be we can start from the right hand side. Cot square theta minus cos square theta is there. Best will be we start from right hand side itself. What I do, I start from the right hand side, since you have asked for the proof for the third one. This is the cos square theta and minus cot square theta minus cos square theta. So I replace this by cos square theta by sine square theta. And this is cos square theta, fine. Let this be cos square theta. Okay. If you take the LCM, LCM is sine square theta. LCM is sine square theta, and this is actually cos square theta minus cos square theta into sine square theta. Take out cos square theta common from here. You are getting cos square theta times 1 minus sine square theta divided by sine square theta. Ultimately, you are getting cos square theta divided by sine square theta into 1 minus sine square theta, which is cos square theta. Isn't it? Sine square theta plus cos square theta is 1. So 1 minus sine square theta, which is cos square theta. Fine. So ultimately, this is cos square theta, and this much is what? Cot square theta. So cot square theta into cos square theta. Okay. So it's better to prove on the right hand side sometimes. Easier to prove. Okay. As I said, read the formula, study the formula, because these are the basic identities I'm giving you. There are more identities. More identities, compound angle formulas, allied angle formulas, so many things are there. Multiple angle, sub-multiple angle. Okay. Some difference and all these things will be sine A plus B, cos A plus B, so many formulas there. Product into sum, product like product to sum, and then sum to product, difference and all these things will be there. So obviously you will need a lot of formulas. So study the formulas. Best thing is you make your own formula books, like how I used to study. The formulas is actually I used to make my own formula book. Okay, own formula book where I used to take down the formulas actually by which I used to study. And years after years, I'm saying the students to do the same thing. Either you make your own formula book. Number one. Number two, also you take the formulas in a sheet and paste it somewhere on your wall, on your study table, anywhere you want to paste it. Just go through it every day, because after this thing, if you're in 12th, after this formula, there are huge number of formulas in inverse trigonometry. I'm telling you. When we start inverse trigonometry, there are a lot of formulas. There are around more than trigonometry, you have a lot of formulas in inverse trigonometry. So throughout in mathematics, in your apart from physics and chemistry, in your mathematics, you will face the most of the formula sets over here in mathematics. But nothing to do, you have to remember this. But in case if you're going to sit for competitive examinations, obviously I told you more formula sets will be there than what you're studying for your NCERT school level syllabus. In your CBSE or your ISC, CBSE, whatever you're studying for, though there we have limited number of formulas, but here we have huge number of formulas. Okay. Even I don't remember all the formulas, but nothing to do. You have to remember this because you're going to sit for the examinations. There are a lot of formulas. Okay. So tomorrow we are going to solve a lot of questions based on this. So I'm plotting a class tomorrow at 3 o'clock. Fine. 3 o'clock is final. Shall I plot a class at 3 o'clock?